Hey guys, welcome back. This is section 1.4. We're going to take a look today at quadratic equations and the three methods of solving them. Oh, focus, focus, focus. All right, so I'm spelling quadratic equations. All right. So a couple of things. First of all, the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. There are three ways we can go about solving a quadratic equation. The first way, we did a little bit of review of already, but this is factoring. As an example of that, we can do, let's see, x squared minus 8x plus 15 is equal to 0. This is a quadratic equation. I've got x to the second minus 8x plus 15. And when you factor, you look at it and you think in terms of I've got two numbers that are multiplying to give me a 15 and add to give me a negative 8. And so these would factor into x minus 5, x minus 3 is equal to 0. We're going to use what's known as the zero product property, because if x minus 5 times x minus 3 is equal to 0, so if two numbers are being multiplied together to get 0, then either the first one is 0, or it could be that the second one is 0. It could be that they're both 0, but we're going to go with the first or the second. This gives us two little mini equations to solve, and we get that x is 5 or x is 3. So our first example of solving a quadratic equation is by factoring. The second example is completing the square. Now, we talked a little bit about this last week, and you guys had wanted some more examples. So I had Todd bring in a worksheet. We can look at that again when I get back on Monday. It is not an assignment per se, just an FYI, but extra practice for you. So here's an example where it would be a good idea to complete the square. Here I've got an x squared minus 6x, and let's say minus 14. Let's do minus 14. Okay. So when I look at this problem, I notice a couple of things. First of all, it's a good candidate because there is no leading coefficient. It's a good candidate for completing the square because there is no leading coefficient. Secondly, the middle term is even. That's always nice because when you complete the square, you have to take half of this middle term. And if it's an even number, that makes it way easier already. The minus 14, I'm going to move over to the other side. So this is going to give me an x squared minus 6x equals 14. Now the idea here is to take half of this and square it. So 1/2 of negative 6 is 3. So I am going to add to both of these sides that negative 3 squared. Oops, squared. There we go. So on the left side, that's going to be a square, multiply double squared. So this is going to be an x minus 3 squared is equal to 14 plus 9, or x minus 3 squared is equal to 23. Now, I can just take the square root on both sides. The square root of x minus 3 squared, square root of x minus 3 squared is just x minus 3, and that would have to equal the absolute value of 23. No, I don't want absolute value. I want the square root of 23. There we go. Plus or minus the square root of 23, because we don't know if it's a positive or a negative. So I want plus or minus square root of 23. Then I'm going to add 3 to both sides. So x is 3 plus or minus the square root of 23. There we go. And I have completed the square. X has two solutions. Once again, I have x could be 3 plus the square root of 23, and I could have x could be 3 minus the square root of 23. There you go, positive, negative, completing the square. The third method is the quadratic formula. which I think we talked about this too, but it's been a while. The quadratic formula is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You may know this as it goes to the tune of Pop Goes the Weasel. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that's the only time I'll sing it. But, now you've got it on record. Okay, so if we were going to do a completing the square problem, a quadratic formula, we might have x squared minus 7x plus, let's say, 15 is equal to 0. And what we would do here is we would identify the a, the b, and the c as based on the standard form. So our a value would be the 1. B would be what's in front of the x, or minus 7, and c would be the 15. And putting that into the quadratic formula, we would have x is equal to the opposite of b, that's a positive 7, plus or minus the square root of b squared. So that's going to be a negative 7 times a negative 7, so 49 minus 4 times a times c. Right? All over 2a, so that's going to be 2 times 1. So we're going to get x is equal to a 7 plus or minus the square root of 49 minus 60 all over 2. Some of you are going to recall this will be the square root of a negative 11 all over 2. That's how you would use the quadratic equation. This answer represents 2 possible solutions. That's 7 plus the square root of a negative 11 over 2, and 7 minus, that didn't show up, square root of a negative 11 over 2. Some of you may remember the square root of a negative number and how that does complicate things. So let's get into that for a minute. All right. One of the things that we want to talk about here is the idea that the discriminant is an important part of the quadratic equation. The discriminant, so the discriminant is the square root of b squared minus 4ac. The discriminant is this part right here. This part, all of this is the discriminant. And we've got 3 different cases, again with the 3's, right? So if that b squared minus 4ac, if that part of the quadratic formula is greater than 0, then there are 2 solutions. 2 solutions that are real numbers. Okay, meaning you could get like a 4 and a negative 7/8, or a 12 and a negative 2, right? If that part is greater than 0, then there has to be 2 real number solutions, because you're going to get b plus that over 2, and you're going to get b minus that over 2. So both of that will work. If that b squared minus 4ac is less than 0, then your solutions will not be real. And in fact, what you will have is 2 complex solutions. So remembering complex numbers, that's where I is equal to the square root of a negative 1. We saw that in the previous example where we had, what was that, 7 plus? That was 7 plus the square root of a negative 11 over 2, and 7 minus the square root of a negative 11 over 2. These are both complex numbers because the square root of 11 we would rewrite as 7 plus I square root of 11 over 2, and 7 minus I square root of 11 over 2. And we'll be doing a little bit more with complex numbers as the term goes on, but the important piece here for right now is that if the b squared minus 4ac is greater than 0, you should get 2 solutions. And if the b squared minus 4ac is less than 0, you will have 0 real number solutions. There is a middle ground between having 2 real number solutions and having 0 real number solutions. And that occurs if that b squared minus 4ac is equal to 0. If that b squared minus 4ac zeroes out, then there is just one real number solution. Because if that zeroes out, then you would have the opposite of b plus or minus 0. And when you have the plus or minus 0, that's just b. So it ends up being just the b over 2. So you may want to make note, right, that this would look like opposite of b plus or minus the square root of b squared minus 4ac all over 2a. If that, I forgot my c. There we go. If this zeroes out, you're just going to end up with the opposite of b over 2a. Okay? And that's just one real solution. All right. So let's try some problemas. All right. So the problem set in your textbook is at the end of section 1.4. I am looking at pages 123 to 127 to pull these problems from. And first of all, we'll look at number 35. Number 35 says use the quadratic formula. I think it even says use the discriminant and the quadratic formula to solve. All right, what's the problem? 3x squared plus 6x minus 5 equals 0. All right, quadratic formula again is x equals the opposite of b plus or minus the square root of b squared minus 4ac. I always forget the c. All over 2a. Looking at this particular problem, this particular quadratic in standard form, 3 is my a, 6 is my b, 5 is my c. Now, some people will do the discriminant first, right? And they'll just look at this and they'll say, okay, b squared minus 4ac. b is 6, so this will be 6 squared minus 4 times 3 times the negative 5, or 36 plus 60. 12 times 5 is 60, negative times negative is positive. So this will be 96. This is a positive number. It is not zeroing out, so I should have two solutions, 2 real solutions. I should put the word real in there. Okay, so when I put that into the formula, this would be the opposite of b, so negative 6 plus or minus the square root of b squared minus 4ac, which I already found to be 96, all over 2 times 3. All right, so this will be a negative 6 plus or minus the square root of 96. Now, traditionally, we would do this square root in simplified square root form. If you have a very specific calculator, it does it for you. If you don't have a specific calculator, then you got to do it old school, which is to say I got to take 96 and recognize that that is 2 times 48, and 48 is 3 times 16. So that's going to be the square root of 16, which is 4, times 2 times 3, which is 6. All over 6, or splitting this up, -1 plus or minus 2 square roots of 6 over 3. Here we go. Separating those out, I've got a -1 plus 2 square roots 6 over 3, and a -1 minus 2 square roots of 6 over 3. I think the WebAssign wants you to give the smaller one first. So this one would be more negative. So this would be the lesser answer, and that would be the greater answer. So the smallest answer first would be the -1 minus 2 square roots of 6 over 3, and then -1 plus 2 square roots of 6 over 3. All right. Okay. Then we've got problem 73 from that same area. Let me pull this. This is a word problem. I wanted to make sure to get a couple of these in here. So number 73 says the area of the figure So they give you the area of the figure as 1,200 centimeters squared. And then they do give you a drawing, which is essentially a rectangle with a triangle hanging off the side. You know, this is X, you know, this is X, and you know, this is 1. Oh, hold on. It did that thing where it froze. Okay, there we go. All right, does that sometimes. So the area of this figure. Now, can you see the two figures? And the idea here is that you recognize this as the area of the triangle plus the area of the rectangle, and that has to equal 1,200 centimeters squared. The area of a triangle is 1/2 times the base times the height. The area of the rectangle is the length times the width. Together, that's 1,200. So this is going to be 1/2. The base of the triangle is X. The height of the triangle is also X. Plus the area of the rectangle is the length times the width, or 1 times X. Okay. All right, so X times X is X squared. We wanted a quadratic, so this will be 1/2 X squared plus 1X, and that's got to equal 1,200. Now, I don't like the fraction. Some of you will be just fine working with the fraction. I don't like it. Since I have a denominator of 2, I am going to go ahead and multiply both sides of this by 2 in order to eliminate that denominator. That's going to give me X squared plus 2X is equal to 2,400, or X squared plus 2X minus 2,400 equals 0. All right, couple of different things we could do here. I actually might have been quicker if I'd used completing the square, but it's okay. So if I go ahead and use the discriminant, so if I use b squared minus 4ac, let's just make sure that I'm going to get real number solutions. So that's going to be 2 squared, which is 4, right? Because this is 1 is my A, B is 2, and that's C. So that's going to be 2 squared minus 4 times 1 times a negative 2400. Oh, I put it up here. So I've got 4 plus 4896. So that's going to be 9600 again. All right, so that's going to be 9604. And that is indeed going to be a positive number. So that's going to give me 2 real solutions. So x is going to equal the opposite of b plus or minus the square root of b squared minus 4ac. That's a 9604. All over 2 times 1. Okay, 2a, 2 times 2. So this is going to be a negative 2 plus or minus, square root of 9604. Ooh, before I break something. All right, so when the numbers are big like that, I tend to check them out, right? Second square root 9604. What's 69? 9604. And it's 98. Okay, so it's negative 2 plus or minus 98 all over 2. Negative 2 plus 98 over 2, which is, let's see, 96. Divide by 2, 48. And the other solution would be a negative 2 minus 98 over 2, and that's going to be a negative 50. So that should give me my 2 solutions, except, good catch. There's a catch here. Can I use both of those? I can't use the negative 50, right? I have 2 numbers that work. The only problem is if it's really area, then I can't have a negative measurement work for my area because we're not talking about black holes here. So it's got to be 48. So this has to be the winning solution, and that one is eliminated. So our x, what do I want here? My x is 48 centimeters. Beautiful. Okay. Very nice. And then I've got one more. This is problem number 85. It's known as the falling body problem. Okay. And it says specifically to use the formula that it gave us in an earlier problem. I lost my pen. All right. So it says from example 7, use that formula where the height of an object of a falling body is equal to negative 16t squared plus the velocity, initial velocity times time from example 7. Okay, so it gives you the formula that you're supposed to use here. H is the height of the object. V0 is the initial velocity. So what does 85 say? It says a ball is thrown straight up at initial velocity, NITIAL, velocity of 40 feet per second. Okay. When will the ball be 24 feet high? All right. So it's important to note that they've given us different pieces of this, that they have told us what the V0, the initial velocity, V sub 0 is, and they've given us the height, so that's the height. This gives us an equation, or we should be able to put together an equation from this. 24 is equal to a negative 16 t squared plus 40, that's my initial velocity, t. Do you see the quadratic? 0 is a negative 16t squared plus 40t minus 24. All right? There's a few things that can happen here. One of the things that I like to do when the numbers are big, like 16, 40, and 24, is I like to divide out what I can. 16, 40, and 24 are all divisible by 8. So I'm going to go ahead and divide each one of the terms here by 8. And I know I put it in yellow. You can't really see it. But that's a perfectly legal move. Divide by 8, divide by 8, as long as I do it to all, right? So that's going to give me 0 is a negative 2t squared plus 5t minus 3. And the beauty part of this is now I've got much smaller numbers. If I'm going to use the quadratic formula, if I'm going to check using the discriminant, I can indeed do this quickly. Here's my A, here's my B, and here's my C. So the possibilities for x could equal the opposite of b plus or minus the square root of b squared minus 4 times a negative 2 times a negative 3 all over 2 times a. So this is going to give me a negative 5 plus or minus the square root, that's 25, and that's 24. But that's going to be minus, so that's going to be 25 minus 24 all over negative 4. So negative 5 plus or minus the square root of 1 over a negative 4. So negative 5 plus 1 is a negative 4 over negative 4, that's 1. And negative 5 minus 1 is a negative 6 over a negative 4, or 3 halves. Right? Beautiful. I think, let's see. So, when will the ball be 24 feet high? If that's right, then when I put it back in, when I put 1 in, I get negative 16 plus 40, and that is indeed 24. And if I put in 3 halves, I get a negative 16, 9, 4. So I get a negative 32 plus 40 times 3 halves, 60. Wait, negative. I'm squaring. Okay, if I take 3 halves and square it, I get 9/4. If I put that in, that's a negative 4 times 9, which is a negative 36, plus 60, which is indeed a 24. Okay, so they both check. So this guy works. Yeah, beautiful. I just wanted to make sure it worked. So I needed to check it. And I can check it in my head, but maybe you can check it using a calculator, right? So maybe you do, let's clear this. You do negative 16 times 1 squared plus 40 times 1, right? You just plug your 1 in and you hit enter and you get a 24, which was indeed what we were intended to get, right? We were supposed to get a 24, we got 24. And then the other option is, instead of that 1, to insert, what do I got? A 3 halves, 3 halves. Delete, squared plus 40 times 3 halves Hunter. I still got 24. So both of my solutions worked. That's fantastic. All right. Part A asked, when will the ball be 24 feet high? But there were some other questions too. I don't have them in front of me, but I do remember one of them. One of them was, when will the ball hit the ground, right? The part B, I think, is, when will the ball hit the ground? All right. So using that same velocity, we're going to have the height is equal to a negative 16t squared plus 40, right? Yeah, plus 40 times t. So the velocity times t. But we need to think about what's happening when the ground is hit, when the ball is hitting the ground. So when the ball is hitting the ground, then our height is technically zero, right? When the ball hits the ground again, our height is exactly zero. So we're really solving 0 is equal to a negative 16t squared plus 40t. Now, there are lots of ways to solve this. I'm going to solve this one not using the discriminant and the quadratic equation, but I look at this and I think, okay, I'm going to factor. And then I can go ahead and use the zero product property, which says if I'm multiplying two things together and they're equaling a zero, then either the first thing is zero, well, times zero, we're assuming it's coming from the ground, or it could be that the negative 16t plus 40 is zero. And if this is the case, then 40 is 16t, and 40 over 16, or 5 over 2, is t. So this is 2.5 seconds. Because in case I wasn't clear, t is time in seconds. And this is at 0 seconds. So we have two possible times when the ball is hitting the ground: at 0 seconds where it started, or at 2.5 seconds in. Right? Now, I am going to go ahead and put in some, that's as big as it'll go. All right, I'm going to put in some additional tutorials for these three methods, and one that has some word problems. I'm just going to link them in the announcement, and if you need a few more resources for this particular section, just reach out and let me know. If not, you're all good. I will see you guys on Monday. I hope you have a good weekend. Stay safe and stay healthy. All right. Thanks.